All right, we're going to look at representing the slope with an equation, and the equation that we use in 8th grade is slope-intercept form. Again, that is in your reference material, and that's y is equal to mx plus b. So the equation must be in slope-intercept form, and that's y is equal to mx plus b. So our m is our slope, and our b is our y-intercept, all right? And you just have to go with it that slope is represented with an m and y-intercept is represented with a b. All right, so slope is the coefficient of x. So slope is the coefficient of x, and that's the number in front of x. Again, this is on your reference material, slope-intercept form, y is equal to mx plus b. All right, so we're just going to look at these equations, and we're just going to identify the slope and the y-intercept. So we have y is equal to mx plus b. The m is my slope. The b is my y-intercept. So you literally just have to pull that out of the equation. So the slope is that coefficient of x, that number in front of x. So slope in this case is that 4/3. And my y-intercept, my b, is that number after the x, and the sign has to go with it. So this is a -12. Okay, so my slope for this example, that coefficient in front of the x is -3. For my y-intercept, it's that number at the end, which is -2. Make sure you take the sign with it. Okay, so my number in front of my x is 15, so my slope is 15. My y-intercept is a +7. My slope is 1/2. And my y-intercept is a -3. It's as easy as that. All right, so we can find slope from a table. And to do that, we find the constant rate of change. All right, find the constant rate of change of the x values and the y values. Okay, and you write that change as rise over run. Okay, and a way that you can use your reference material, if this still kind of looks strange to you, is just kind of cover this part up and just look. We have y over x. Okay, so we're doing the change of y over x. Okay, so here's a couple of tables, and we're looking for that constant rate. So you're looking for a pattern. Okay, we're looking how our y's change and how our x's change. So just look and see what's the difference here. What's the difference between -1 and 0? Okay, well, to get from -1 to 0, we're adding 1. To get from 0 to 1, we're adding 1. To get from 1 to 2, we're adding 1. All right, to get from 0 to 2, we're adding 2. To get from 2 to 4, we're adding 2. To get from 4 to 6, we're adding 2. So that's our pattern. So our slope is that change in y over that change in x. So how are my y's changing? My y's are changing by 2. And how are my x's changing? My x's are changing by 1. Okay, so, and then 2 divided by 1 simplifies to be 2. So for this table, my slope is 2. All right. Now you can also find, I'm just going to write that down here, slope is 2. We can also find our y-intercept from the table. And so our y-intercept is where x is 0. So when x is 0, my y is 2. So in this case, my y-intercept would be 2. All right, so then this table here, oh, this one is written horizontally and this one's written vertically, but it's all the same information. So I'm going to look for a pattern. So to get from 3 to 6, I'm adding 3. To get from 6 to 12, I'm adding 6. To get from 12 to 15, I'm adding 3. All right, there's a typo on this. This should be 20. Okay, this should be 20. To get from 20 to 16, I'm subtracting 4. To get from 16 to 8, I'm subtracting 8. To get from 8 to 4, I'm subtracting 4. So I don't have a constant pattern right now. It doesn't look as if I have a constant pattern, but I really do. Okay, so again, our slope is that change in y over that change in x. So if I just look at this first one here, I'm changing by -4 and +3. Okay, if we use the second one here, I'm changing by -8 and +6. Well, isn't -8 over 6 the same thing as -4 over 3? Yes, so when I simplify both of these, they're both going to be that -4/3. So my slope is the -4/3. And my y-intercept is not on the table, but I can find it by counting backwards. Okay, so we were adding by 3. So if I subtract 3 and count backwards, I'll be at 0. Okay, so we're adding 3 each time. But to get to 0, I have to work backwards, so I would subtract 3. Okay, and here I'm subtracting 4 each time. So to work backwards, I would have to add 4. So to add 4, I'd be at 24. So my y-intercept would be 24 in this case. All right, and we can find slope from a word problem. When we're looking at a word problem, we want to look for keywords like each, per, every. And that's going to let us know where the slope is. And this, of course, is our rate of change. Okay, so that slope-intercept form equation is y is equal to mx plus b. So we need to find our slope, our m, and find our b, and then just write it as the equation. So Jack has 5 toy trains. He plans to buy 2 new ones each month. All right, so that y-intercept, that b, where do we begin? Okay, where do we begin? All right, well, we begin with he has 5. Okay, he has 5, so that's going to be my y-intercept. He plans to buy 2 new ones each month. So we're multiplying by 2. This is my slope. All right, and then we just put that all together. Y is equal to that slope of 2x plus where we begin. We begin with 5. All right. Okay, our next example. The initial fee to have a website set up using a server is $48. It costs $44 per month to maintain the website. Well, our y-intercept, our b, where do we begin? We begin with this $48. Okay, that's my b. And it's costing me $44 per month, so I'm multiplying, that's my slope. And then I just put it all together. Y is equal to the 44x plus the 48. All right, my next example. An online camera store charges $1.49 for every 8x10 picture that you order. The shipping cost is $5.50. Okay, so where do I begin? I begin with the $5.50 for the one-time shipping fee. And then I have $1.49 for every photo, so that's going to be my slope. And then I put it all together, so my y is equal to the $1.49x plus the one-time fee of $5.50.